sorry about that. So what I did here, guys, is I took the game 24 and I thought to myself, how did the creators of the game make the cards? And the way they made the cards is they would choose their math facts, like 6 times 4, and then they would create 6. And they would say 9 minus 3, 5 minus 1 is 4, 6 times 4 is 24. Bogdan, question? And you're muted, buddy.
So, can you if you're making 6 and you have 9 and 3, can you put them like across from each other? So 9 is on the left, the middle, and 3 is on the right middle.
Oh, can you go like 9 and 3 like this?
Yeah.
Absolutely. In fact, guys, that's one of the things I wanted to talk to you about. What I wanted to talk to you about was this. How many possible cards are there? You know that you can only have the digits 1 through 9. That means that you could have a 1 through 9 here, a 1 through 9 here. So you can have 9 digits in each one. But let's say, and this goes to Bogdan's question, if you had a card that said, let's say, 2, 3, 5, and 8, is this card any different?
No.
Than that?
No, because it's the same numbers, just in a different order.
It's a different order, and guess what, guys? We do not care about the order. So these are called the same cards. So I did some really fun calculations, and I want to show you. You don't really know this math yet, I don't believe. But if you have the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we think, how many ways can we choose 4 numbers? Now, these are called separators. These lines that I'm creating here, who can tell me how many separators I have?
8.
Do you guys see 8 separators?
Mm-hmm.
Now, if I were to put X's for all of my numbers, do you know what card that represents?
9.
2, 3, 5, 5.
Thank you. 2, 3, 5, 5. Exactly right. So that represents a 2, 3, 5, 5. Now, I'm going to erase those. And I'm going to put my 4 X's here. What does that represent?
6, 7, 7.
That's right. Now, here's what I thought about. I thought, wait a minute. If I can let my X's equal the numbers, and let my partitions equal the different ways to organize the numbers, if I add 8 plus 4, I get 12. So if I take 12 items and I choose 4 at a time, that's going to give me the number of different cards. Now, I don't want to spend a lot of time going over this math because this is what I did with my my 5th, 6th graders this week. When you take 12 items and you choose 4 at a time, the way to solve this, you use factorials. Can anybody tell me what a factorial is? And I'm going to start with Brody.
So it's basically the number times all of the remaining numbers below it.
So 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Can anybody tell me why I did not write times 1?
Because
Bogdan, why?
Because it's going to be the same thing.
Yes. And now who can write for me, Vrenny? Can you write for me 8 factorial? How would I do that below?
Eight times 7 times 6 times 5 times 4 times 3 times 2.
Beautiful. And Haley, how could I do 4 factorial?
4 times 3 times 2 times 4 times 3 times 2.
Yeah, now it was really neat that you were going to say times 1, and you could have said times 1, but I just want to simplify as much as possible. Now, do you think that this would be a very difficult number to find?
Yeah. So you
No.
pick out the
No.
Guys, do you
Oh,
know what, guys, who can tell me what 8 divided by 8 is? Pete, do you know that? 8 divided by 8? I couldn't hear you.
Sorry.
It is 1. Let's see. Frenny, 7 divided by 7.
1.
Reed, 6 divided by 6.
Oh, it's just 1.
answer.
Evan, 5 divided by 5.
1.
Cole, 4 divided by 4.
1.
Brody, 3 divided by 3.
1.
And Bogdan, 2 divided by 2.
1.
And basically, 8 factorial divided by 8 factorial, guys, is 1. So they all cancel. Now, who can tell me what else cancels here? I've got a 4 and a 3 on the bottom and a 12 on top. And Reed, can you not do that, buddy? Can you sit up, please? So 4 times 3 is what, guys? What is 4 times 3?
12.
Oh. So can't we do 12 and 4 and 3?
Yes.
And who knows the last thing we can cancel here? Flag in, don't say it out loud. The last thing that can cancel here. Cole?
10 and 2.
And 10 and 2 become what, sir?
5. 0
Yep.
and 1 and 5.
And guess what we're left with? Everybody say it. 11
11.
times
5.
9.
Now, I'm going to teach you guys a little trick. Whenever I have the number 11, I never multiply it first. I always multiply my 5 times 9 is what?
45.
45.
And I write the number down twice. And I add them. But who can tell me, did I do this in a funny way?
No, you put a 0 under the top 5.
So isn't this really 10 45s and this is 1 45?
Yeah.
Which is how many 45s?
11.
A lot.
And there we go, guys. There are 495 possible cards in this game. Now, guess what I found out?
How many combinations there are?
Yep. Well, we just found that out. So the number of combos,
No, combination of colors.
there are only 495 possible cards. But there are a certain number of impossible cards. And I've been working on this for a long time. There are 91 impossible cards. So for instance, the card 1111 is impossible. 2222 is impossible.
1, 2, 1, 2.
Definitely impossible. Anybody can give me, what about 3333? Did we solve
Yeah,
that
we
one?
did that. We did that.
Yep. So these are impossible.
10, 10, 10, 10.
Well, 10 is not a single digit.
Read 9.
Only use, now, nines,
Yeah.
I'm pretty sure that that's impossible.
9,
What
1,
else do you think we can try?
9, 1, 9, 1.
Well, in the same light as this.
Oh. 8, 8, 8, 8.
8, 8, 8, 8.
8 plus 8.
Wait, you guys want to try, but not out loud though, Reed. So everybody try 8, 8, 8, 8. I'm going to write it over here. 8, 8.
Oh, wait. I just did.
But read
Yeah,
not out loud. Read not out loud. So if you don't think out loud, everybody gets to think about this. Okay? So I want you guys thinking. of ways to make it work. And if you're not picking up that pencil, there is no way this is happening. No way this is happening. Yeah. So guys, I believe that this is one of those impossible cards, but I tell you, this is not. Can you guys solve the sixes? Wait, Cole, you've already got it?
Yeah, 6 plus 6 plus 6 plus 6.
Yeah, guys, pretty simple.
Or 6 times 6 minus 6 plus 6.
6 times 6, which is 36, minus, oh my God, Evan, that was fantastic. Beautiful job. Who can keep going on this? Pete.
That was from before.
Oh, okay. Good. Isabella, you got one?
I'll think. 6 plus 6 plus 6 plus 6.
Yep, that's absolutely right. 24, beautiful job. Now, let's move to 5, 5, 5, 5. And I want you guys really thinking about this one. And I really like this one. There's got some beautiful solutions with this one.
Let's think.
But I can't think of a lot though.
I got your numbers in the bag. Calculators attached. Numbers in.
Okay, Brody, start us off.
5 times 5 minus 5 divided by 5.
25 minus 1, guys, is 24. And that's pretty much what I came up with. And I don't know, are there any other strategies? Reed, did you have any other strategies on this?
Well, I had a slightly different one.
Go for it, man.
I actually, it came out the same thing, but my strategy was add them all together, and then see what number it gave me, then subtract half, and then try multiplying two of the numbers, and that gave me 25. I was like, I have 2 5s. Oh, 5 divided by 5 is 1.
That's right. That's right. Very nice. Now, guys, I went through every possible iteration, and I found that there were 91 cards that didn't work. Now, if there are 495 possible cards and 91 cards that don't work, who can tell me how many cards actually do work?
Mom, someone's
Are you
face.
thinking about this? Haley, go for it.
Wait,
So how many cards actually work?
404.
Everybody agree with that?
Yes.
Yeah, wait. I
Now,
got, does 1, 2, 3, 4 work?
well, we'll look at that.
Because
Yes, it does work.
Yeah, do you
Because
see,
2
guys,
times 3 times 1 times 4.
do you guys see 8 times 3 here?
Yeah.
You guys see an 8 times 3,
Yeah.
right?
Or 4 times.
I got another
4
one
times
though.
6. 4 times
Ready?
6.
How about 6? No, sorry. How about 6 times 4?
There's also another 6 times 4 because 2 plus 1 plus 3 is 6 times 4.
Oh man. Or 3 times 2 times 1. Isn't that what Brody said?
yeah.
Yeah.
Right? That's what Brody said. So Reed, that was a really good one. Now, what I want to ask you guys is this. What percentage of possible cards have solutions? So I don't want an exact number. You know that 404 over 495 cards have solutions. Can anyone tell me an approximate percentage? And don't say it out loud. And the best way to do this is think of numbers that are really close to 404 and 495, and then think of what percentage that would be. So Rennie, what number might we use for 404? What would be like a good estimate number?
400.
I like it. And Brody, can you give me a good one for 495?
500.
Now, before anyone tells me the percentage, Evan, can you tell me how to simplify that guy?
4 out of 5.
And who can tell me 4/5 is equivalent to how many tenths? Cole?
8 tenths.
And what percentage is that, everybody?
80% of
So guess what? 80% of the possible cards have solutions. And that's why I thought that they chose the number 24 to make this game. But guess what? I was wrong. Because I found an analysis created that shows all the target numbers from 0 to 99, and out of a possible 495 cards, how many? So the number 0, if this game were called 0, 485 cards would be possible, which is 97%. Now watch this. If the game were called 97, only 8% of the cards, only 42 cards would be possible. Isn't that amazing? Can anybody tell me why the number 97 doesn't work for a lot of cards? Who can tell me what is special about 97? Bogdan, we'll start with you.
It's very large. It's a big number.
It is large, but it also has some, because look at 99. That's even larger, and it's got 21%. Who has an idea for me on that? Oh, Evan?
I think that it maybe could be how the fact that 97 doesn't have a lot of factors.
It's prime.
Guys, 97 is a prime number. How many factors? Evan is right. How many factors does it have, guys?
2.
Only 1 times 97. So the only ways to make 97 are to kind of combine other numbers together. And so, but here's the thing that really surprised me. The thing that really surprised me was this. The number 24 is the 19th on the list. That means that there are 18 target numbers that have a higher percentage than 24. And so Why did the manufacturer use 24? I do not know.
And better sales?
I don't know. I really don't know. Now, I thought I would give you guys all of the 91 impossible game cards. So these are the ones right here. Remember how you said 999, 111. Now look at this. 1, 2, 1, 1, 2, 3 is impossible. 8, 8, 8, 8, 2, 6, 7, 7. So these are the 91 impossible numbers. Now, what I want to show you guys is this. I want to go to...
Zeros impossible numbers?
Say that one more time.
No, I was just guessing you would go to zeros impossible numbers because that's the most likely. And
Say that one more time. I don't understand what you're...
I thought you would go to zeros impossible numbers and see which ones are the same and which one's the different compared to them.
Oh, my God. That is...
I was just guessing that may have been what it was.
A lot of feedback there. That is an amazing, that is a truly amazing idea, guys. If we could figure out the 10 impossible cards for 0, I think that would be really cool. I think that would be truly amazing. Bogdan, what do you think?
I was gonna ask, which number has the most? Oh, 0. Okay.
Well, wait a minute. I don't know. No.
2.
Bogdan, look at this. 2 actually has 99%.
Jeez.
Let's look at the list. And by the way, this is on the second to last page of your packet. Look at that, guys. There is no number that does better than 2. But you know what? If the game were called 2, do you think a lot of people would like it? Hey, let's go play 2. But let's go play 24.
I mean,
Now
that's a new game. Dos.
Wait, say again?
That's the new version of Uno, Dos. And that's in Spanish. They could have just called it Dos, but when this game was made.
You know, I have to tell you, if I were making this game, I might make it as a 1. The other number that I really like is the number 48. Now, I want you guys to take 2 minutes right now, 2 minutes, and I want you to factor the number 48 using my factor method. Remember, always start with 1 and 48. All right, go. Everybody do it. Come on. 1 and 48, double and half, double and half. And don't call it out, please. And if you did that one, if you finished that one, then you can factor the number 96. So remember, this is not a mental exercise. This is something you do with your pencil. Come on, take double and half, double and half, double and half. And Pete, I really like what you chatted to me. Your percentage was right on. Right on. All right. Everybody look up. Let's do this as a team. And I want you guys to get a rhythm. Are you ready for a little rhythm? Let's do double and half. Go, go, go. Give me a 2.
2,
And
24.
24. Give me a
4,
4.
4.
And
12.
give
12,
me a 12. Give me a
8,
and
6,
6.
give me a 6. Right? This is going. Give me a 6. Keep going.
16,
16. 3. 3.
Now, do you guys notice that when you get down to 3, because it's a prime number, that we are done?
Mm-hmm.
Isn't that cool? So in my method, you're done when you get down to 3. Now, the next thing I want to show you is I want to show you the game cards. Now, I'm not sure. Let's see. There are 6 cards. There are 18 cards on that page. Whoops. There are 24 cards on that page. So take a tally, guys. So 18 and 24 plus 6. So 18 plus 30. So there are 48. I'm going to write this down somewhere. There are 48 one-dot cards. Now, one-dot cards are the easiest. Let's look at the two-dot cards. Well, you know what? Let's just count clusters of 6. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Flag in if you could do 16 times 6. 16 times 6. On 3, 1, 2, 3, go.
96,
There are 96 two-dot cards. And then there are 3 clusters, 7, 8. 8 times 6, everybody?
48.
48,
8 times 6 is 48. So there are 48 3-dot cards. And if you add those together, you get how many cards? Remember, 48 and 48 is 96.
182.
195. Oh, yeah.
One, pretty close. So 192 cards, guys, is how the game is played. And I literally gave you all the cards. I gave you all the cards. But remember, there are other ones. Now, we're going to actually play a game right now. And we're going to start with 2-dot cards. And I'm going to let, Haley, I'm going to let you choose a card on this page. Go for it.
The first cluster, the last one.
Can you say the numbers, please?
5, 8, 6, 4.
All right, everybody get working. This is a 2-dotter, 5, 8, 6, 4. And remember, if you come up with one solution, go for more. Cole, you working it?
Yeah, my pencil lead just broke.
Okay, so go get another pencil, please.
No, I have more in my folder.
Then go get your folder.
It's with me.
Then get your pencil. Now, you guys write down the numbers because I'm going to start writing my solutions on the page. and I don't want you guys to look at them just yet. So write down the numbers, and Haley, you got to be starting to calculate. That's what you want to do. This is all about calculation. All right, do you have any solutions yet?
I got one.
Still working them?
I got one.
Cool, cool. Keep working on alternative solutions, please. And Evan, you're still with us?
Yep.
Okay, good man. I don't see you. And Pete, the answer is yes. It is a very cool strategy. And Pete, I'm going to show you. And Pete, do you understand the whole concept of the halves?
Yeah.
Okay, cool. And just let me just show you another example, Pete. If I'm doing 100,
Mm-hmm.
you see how I have 1 and 100,
Mm-hmm.
and then 2 and 50,
Yeah.
and then 4 and 25. Pete, look what happens when I hit 25. I can't do 8 and 12 and a half. So I then go to 5, right? Because that goes into 25. 5 goes into 100 how many times? And then I do double and half again. Isn't that cool, Pete?
Mm-hmm.
So that's another solution. Okay, so Bogdan, can you share with us your solution for this one here? Go.
Okay. So it's 5 plus 4, which is 9. 9 minus 6 equals 3. And 3 times 8 is 24.
And 3 times 8. Now, guys, just so you know, there are many, many different ways to get 3 from 4, 5, and 9, and 4, 5, and 6, just kind of different methods. But frankly, this is all about 3 times 8. So the one that Haley just chose is all about 3 times 8. Now, would you guys be nervous about trying a 3-dotter? Or do you think we should do it? Oh, and Reed, you're muted. So I'm gonna, because I think you're trying to speak to us.
Where did you get the 8 from? It would be 3 times 9 for 27. 5 plus 4 is 9, not 8.
Yeah. But then when you do 5 plus 4 is 9.
Mm-hmm.
And then 9 minus 6 is 3. And then 3 times 8 is 24. Does that make sense?
Yeah, it makes sense now.
Okay, awesome. Now, let's choose a 3-dot card. Now, these are crazy, crazy fun. So who's going to choose? Brenny, can you choose a 3-dotter for me, please?
Sure. Wait, hold on. Yeah, sure. 6, 2, 9, and 8. That
6,
one.
9, 8. Where is it? Where is 6, 2, 9, 8?
It's right above the blue.
Above the
cards.
blue. Oh, I see it. 6, 2, 9, and 8. Wow. Of course, Brenny, you chose a very challenging one. I love it. I love it.
All right, let's get walking.
And I hope you play this with your families.
Well, glancing over one of the cards, I found a solution for one.
Wait, what's that, Evan?
I didn't say anything.
Oh, who said something?
Do you get points for finding 25?
You know what you get? You get a square. You get it? Because 25 is a square number.
No, I don't get it at all.
5 times 5 is 25. It's a square.
Okay, Boomer.
Ooh, I have a good one, guys. Oh, I have a crazy one. Okay, I'm not going to give it to you yet because it's too crazy.
Oh, wait, no, I didn't find it.
And by the way, guys, focus. Focus on my favorite math fact.
Cats are cute.
You can do this.
Oh, I got it. Oh.
Okay, send it to me in a chat.
All right.
And Haley, you working on this? So I didn't see you. Oh, good, good. You're still there. Good. Oh, and Pete, just so you know, Pete, the dots are difficulty level. So the more, like the 1 dotters are the easiest, the 2 dotters are middle, and the 3 dotters are fun. Really fun, crazy. So guys, come on, look at that 9, that 2, and that 6. You've got to be able to get a 3 with those guys.
I go.
Go ahead, Bogdan.
So 9 times 2, which is 18, and 18 divided by 6 is 3, and 3 times 24 is, 3 times 8.
Now, everybody look up. Get me another way to get 3 from those numbers. Go, Brody.
Wait, would that work?
Hold on a second, Reed. Go, Brody. Oh, Brody, you are muted. Go for
I had
it.
the same as Bogdan's. I forgot.
Oh, wow. Okay, and did you have another one, Reed?
Yes.
Go for it.
9 minus 6. Multiply it by 8, then throw the 2 in the trash can.
So that is a 3. And then you got a 2 to deal with. You can't, no trash here, guys. There is no trash receptacle.
Wait, then you divide the 2 by itself.
Yeah, but guys, why not divide 6 by 2? What is 6 divided by 2?
3.
3.
And what
then
is
you have
9 divided by 3?
3.
3.
And there you are.
Oh.
Brody, what do you have?
2 times 6 minus 9.
Wait a minute. Stop the presses. Stop the presses.
What about 8?
2 times 6 is 12. Keep going.
Minus 9.
Wow. And then 3 times 8. That is crazy. Now, guys, I want to end this lesson with something a little nuts. Are you ready for nutty Kramer? You ready for this?
I don't believe you're that nutty.
Well, this is about as
I
nutty
don't know this.
as they get. You ready? The first thing I did was 2 times 9.
Back into the corner.
And you would say, Kramer, Brody just did that. That's not so interesting because he already did it. But guess what? We're going to take 18 and we're going to multiply it by 8 divided by 6. So I just left the integer world. I just said, I'm leaving integer world and I am using fractions. Now, do you remember what happened to the 18 and the 6, guys? What does it become?
3.
3 and 1. And 3 times 8 is what?
24.
24.
And that is the craziness. Now, what I want you to do, I was struggling with a particular card, and I want to show you what my struggles were. I had a card that was a 3, 8, 8, and a 3. And I couldn't solve it until I left the whole number world. When I left the whole number world, guys, here's what happened. Ready for this?
Oh, I found a way.
3. Okay, go ahead, Reed.
8 is equal to 8. 3 is equal to 3. 3 times 8 is 24.
Those are true statements, but that equals is not an operation. But that's a good try. Now, you guys watching? 3 minus 8/3. Who can tell me what 8/3 is? Haley, do you know 8/3?
2 and 2/3.
How cool is that? And can anyone tell me what is 3 minus 2 and 2/3? Say it on
1/3.
On 1, 2, 3, go.
1/3.
1/3.
And now watch this, guys. What number have I not used
What would
yet?
that be negative?
I used the 3, the 8, and the 3.
The 8.
What happens if I take 8 divided by 1/3?
24.
The third would be in the negative.
Oh, 24. Why do you say negatives?
Because 3 minus 2/3.
Isn't 2?
Oh, I was thinking of it the other way.
Yeah. So guys, you can also divide by a fraction, which is really multiplying it by the what?
By the fraction.
It's called the reciprocal. So when you divide by a fraction, you're really multiplying by the reciprocal. Now this game, guys, believe it or not, it seems so simple, but it is so challenging. So please take the cards that I gave you and start to cut them up. Literally, cut up those cards, and you can play this game for hours and hours and hours, and it will be a lot of fun,
I
especially.
wonder if I can get off the pages.
Well, you know, one thing you might want to do is you might want to have your parents print this out in color on single sheets.
We
because
have
then
no,
you can cut them out.
we have
and
no
it'd be really
color.
sweet.
We have no
Yeah.
coloring because the
Oh,
ones-
no color, that's okay. You don't have to use color. Now, we're gonna obviously start with the number 24 right now. And I want you to multiply by a half. Are you ready? Go. Negative 24, go.
Negative 12.
Negative 12, go.
Negative 6,
Negative
negative
six.
3,
Negative 3.
negative 1/3.
Negative 1
No, 3 halves, keep
3
going.
halves.
Negative 3/4.
Fourths, come on, keep going.
Negative 3/8.
Keep going.
Never get there. If you
Negative-
don't go
negative-
halfway, you can't get there.
Negative 3 what?
37.
32ths. Negative 3/64ths. Guys, what number are we getting very close to?
0.
But don't ever say negative 0. 2, 4, 6, 8. Who do we appreciate? Mathletes, mathletes, go mathletes. And I'll
Wait.
tell you something. I am going to see most of you exactly in 167 hours, but some of you are going to start in that Wednesday class, and that's, you know how many hours that is from now? It's
Not that much.
144 hours from now. It's a gross number of hours. And so I will see you in a gross, some of you, and some of you I'll see you in 167. And by the way, Pete, keep asking great questions. I want you all to really rock this week with 24, and we'll be back next week
Wait.
with more.
Mr. Kramer,
Yes, sir.
want to know a fun fact?
I do.
2 divided by a divided by 2 divided by a continued is equal to undefined.
So
Because
say-
you
say
never
it.
get
Two-
to
So
zero.
2 divided by 8.
No, a
So 2
variable.
divided by A. Keep going.
And then it's 2 divided by b continued. So it just it just keeps doing variables, is equal to undefined because you can never get to 0.
So 2 divided by A. And
Like,
then what do you want me
let's say A is 8, then it would be 4, then it would be 2, then it would be 1, then it would be 1/2, and you just never get to 0.
Well, you know, it's interesting. Make believe that the red is my starting point and that the green is my ending point. If I go from red 1/2 of the way to green,
Mhm.
here I am. 1/2, here I am. 1/2, here I am.
You'll never get there.
Will I ever get there?
No, so it's
I'll get
undefined.
really close, and that's actually called half-life. It's called half-life. There are certain isotopes that actually do that, and they cut in half and half and half and half, and they will never actually get to 0, which is cool. Anyway, guys, I gotta go. And Cole, you have a question, buddy?
So for these, like, the math sheets that we've done, like, when we start doing, like, actual, like, face-to-face,
Yes.
like, will you, like, give the dollars?
Yes. We,
Oh.
you know, Cole, I've been thinking about that a lot.
What do you mean dollars?
Well, I used to give away Mathlete dollars, which had famous mathematicians on them. And we really haven't done that in the last
2 months.
about 2 months because of the virtual world. So that's something
How about
Cole that
real?
I'm really looking forward to doing. when
Yeah,
we
you
get
can
back
also
to
send them in mail. They'll be in the envelope for 3 days going through the mail system.
Yeah, but you know what? It's a little too dangerous.
Snail mail.
And so I don't want to put anybody at risk. Anyway, guys, it's great to see you. You are the best, and I'll see you soon. Take care.
Bye.